Alright, so polar coordinate system. The polar coordinate system is based on a point called the pole and a ray called the polar axis. So that's what a pole looks like. It's just a ray. Polar axis. Point P has a rectangular coordinates, x, and y. Point P can also be located by giving the directed angle theta from the positive x-axis to ray OP and the directed distance r from the point P. The polar coordinate of point P are r theta. If r is greater than 0, then point P lies on the terminal side of theta. If r is less than 0, then point P lies on the ray pointing in the opposite direction of the terminal side of theta and distance r from the pole. That's just definition work. That's what it looks like. It looks just like what we've been working with x and y coordinate planes. It's because that's essentially what they are. At the very end of everything, it's just an x and y coordinate point. Alright, so the correlation between them, rectangular and polar coordinates. X is r cosine theta. A cosine goes with x, right? Y is r sine theta. Sine goes with y. R squared is the same thing. Is that a typo? Hold on, I think I have a typo here. I was just double checking. That is a typo, sorry. I knew that. Alright, r squared is x squared plus y squared. And then tangent theta, that's the same thing. It's y over x. That doesn't change. Alright, we're going to plot points with polar coordinates. So plot each point by hand in the polar coordinate system, then determine the rectangular coordinate of each point. So we're going to graph all three of these on the same polar coordinate plane. So a polar coordinate plane is a circular coordinate plane. Because when we think of polar, hopefully you think of like the poles, the North Pole and the South Pole, and isn't it like a circular plane? That's what I think of when I think of polar. It just works for me. Alright, part A. We're given P is 230 degrees. So first thing we're going to do is graph this. So do you notice it goes, each one, it's a level. I'm going to write them in blue. This is level, this is 1, 2, 3, 4. So those are like your levels. So if it's 230 degrees, 2 is 1, 2, 30 degrees. I would say 30 degrees is about right there. Using like your unit circle, 30 degrees is about there. So that is our point P. So you count how many like rings you're on. We're on ring 2. And 30 degrees is about there. It's close. Now we need to find the rectangular coordinate points. So we need to find x, which is found by saying r cosine theta. And then we need to find y, which is found by y, or y equals r sine theta. So we have x equals r. R is the actual number they give you, which is 2. Cosine, and then the theta they give us is 30 degrees. So 2 times cosine 30. Cosine 30 is perfectly on the unit circle, and it's the square root of 3 over 2. And when we simplify that, we get our x coordinate is square root of 3. Now our y coordinate, we find it using the same method except for sine. So we have our r, which stands for 2. Sine theta, which is 30 degrees. So we have 2 times sine 30. Sine 30 on the unit circle is perfectly 1/2. So when we simplify, we get 1. That means our rectangular coordinate point is square root of 3, 1. So we're given the polar point, which is 230 degrees. That's the exact same thing as square root of 3, 1 for your x and for your y. All right. I think it's pretty straightforward. I think it's like very just. I just have to like be more comfortable with it, but I think like it's really straightforward. Alrighty, B. All right. R is negative. The number they give us is negative. Because that's negative, we need to be more careful with this. So R is negative, and it's negative 4 2 pi square root of 3. So first of all, we need to figure out where all that is. So negative 4, it doesn't matter that it's negative. We still go in the fourth ring. It's still going to be the fourth ring. But if we go back to our unit circle, all the way back in 3.1, forever ago. Gosh, wasn't that just so long ago? There we go. There it is. So we're talking about 2 pi over 3. 2 pi over 3 is right here. It's right here. I'll circle it. That's 2 pi over 3. But it's negative 4 2 pi over 3. So if we think about it, if we put it in the fourth ring at 2 pi over 3, that's positive. So technically, straight up, where this exists at regular 4 2 square root of 3, it's right here. 2 square root of 3 is, I would say, right there. So this is 4 2 pi over 3. I don't know why I kept saying square root. But we need negative 4 2 pi over 3. So we just create its extension. And that is our Q point. So what you do is you go to the actual radian or degree measure, and you just create the extension of it. That is literally like the verbiage and terminology that is used. You create the extension of the 2 pi over 3 ray. Alright, so which values do we actually use and go by? Do we go off of the negative version or do we go off of the positive version? Do we go off of the original ray or do we go off of the extension of the ray? So if we're working already in 2 pi over 3, it doesn't matter that it's a negative r or a positive r. Just to draw it, we needed to create the extension. But to actually work out our values, you're going to use what 2 pi over 3 is. So let's plug it in to find our x. It's r cosine theta. And to find our y, it's r sine theta. So our r is negative 4 cosine 2 pi over 3. Same thing on the right side. We have negative 4 sine 2 pi over 3. That's another reason why we use just straight up 2 pi over 3, because it's asking us for what is cosine 2 pi over 3, what is sine 2 pi over 3. To graph it, that's where we create the extension, because it wants negative 4 2 pi over 3. Alright, we simplify. We have negative 4 cosine 2 pi over 3 is negative 1/2. So we get positive 2. And then we keep simplifying for the right side. Negative 4 sine 2 pi over 3. Sine 2 pi over 3 is square root of 3 over 2, which we can simplify into negative 2 square root of 3. So our rectangular coordinate point is 2, negative 2 square root of 3. Doesn't that make sense though? Because 2 negative 2 square root of 3, isn't that going to be here? Because 2 is positive, y is negative. So you see how it still worked out? It still matches the drawing. You only do the extension when r is negative. No other time. Only when r is negative. I don't care about y. I don't care about the measure. When r is negative, we have to create the extension. Only with r. We have 5 negative pi over 4. Alright, so r is still positive, but the y, or not the y value, the theta we have, the angle we have is negative pi over 4. So let's go back to our unit circle. So when we're back at our unit circle, remember when we have a negative angle, we count it in the positive direction and figure out how many dots that is? So here, bear with me. So 1, 2 dots in the positive direction. That means you go 2 dots in the negative direction, the bottom. So 1, 2. So what we're actually going to be using is 7 pi over 4. So you go to how many positive dots it takes to get to pi over 4? It's 2 dots. So then we do 2 dots in the negative direction because 7 pi over 4 is the same thing as negative pi over 4. So for C, negative pi over 4, we're actually going to be using the values for 7 pi over 4. So for our x coordinate, we have x equals cosine theta, and then y equals sine theta. In this case, it's 7 pi over 4. Sorry, r. Our r is 5, so we have 5 cosine 7 pi over 4. Then we have 5 sine 7 pi over 4. Alright, we simplify. Cosine 7 pi over 4 is... I just simplified that right away. I'm going to pull up my unit circle. I hate when I do that on my notes. Is square root of 2 over 2. And when we simplify that, we get our x value of 5 square root of 2 over 2. And then our sine value, so 5 times sine 7 pi over 4, that's negative square root of 2 over 2. And if we simplify that, we get our y value of negative 5 square root of 2 over 2. So our rectangular coordinate point is 5 square root of 2 over 2 and negative 5 square root of 2 over 2. And then we are going to graph it, don't you worry. We're going to graph it. I just wanted to get those numbers out of the way. So to graph it, we know negative pi over 4 is the same thing as 7 pi over 4. So 7 pi over 4 is, it's about right here, I would say. It's about right there. So that's our r. Or my bad, 5. I didn't go all the way to 5, so 5 would be here. I didn't go all the way to 5. I only put a 4 polar. That's okay. Alright, so while a given point is the plane, in the plane can have only one pair of rectangular coordinates, this same point can have an infinite number of pairs of polar coordinates. Because polar coordinates, remember, if you have 30 degrees, you also have 360. You also have plus another 360, plus another 360, because you can just keep going around your circle forever. So you can have a 30 degrees, you can have 360, you can have, or it would actually be 720. You can have an infinite amount of polar coordinates because you can just keep going around the unit circle and keep going around the unit circle and keep going forever and ever and ever. All right, example 2, giving alternative forms for coordinates of a point. So we have this drawing here, and we are going to give 3 other pairs of polar coordinates for the point P, 140 degrees, and then we're going to determine 2 pairs of polar coordinates for the point with rectangular coordinates, -1, 1. That's part B. Part B is right there. So part 1, we want to give 3 other pairs of polar coordinates to 140. This is actually the answer. I just wanted to give you a graph to show you what it looked like, but we're going to work it out ourselves. So pretend the graph's not there. Part A. So we have 140. So to find all of our values, we're going to add 180, subtract 180, add 360, subtract 360. We're going to do every possible combination of the unit circle applied to this. So our point is 140. So write it 4 times. We're going to find 4, not just 3. We're going to find all 4. So the first one, you subtract 360. The second one, you add 180. Then we subtract 180, and then add 360. You see how it's adding and subtracting to everything to do with the unit circle? Because we can go around 180 degrees, or we can go around 360 degrees in the positive and negative direction. So 140 minus 360, we get -220. That means our polar coordinate is 220 degrees. Keep going, 140 plus 180, we get 320 degrees. So our polar point is 320, but bear with me here. I'm going to leave this blank for a second. I'm going to leave that blank, don't you worry. I'm going to come back to that with the picture. Our next one, we have 140 minus 180, that's -40. So we'll have blank -40 degrees. There's a reason why I'm leaving it blank, just bear with me here, I'll get back to you. And then our next one, we have 360 plus 140, which is 500. And that's 500. Now, why did I leave these 2 blank? This is where I'm going to help us with our picture. So this is why it's important to graph each of them so you know whether it's a positive or a negative. So I'm going to make each of these really stick out to us. I didn't put 500 on here. That's okay. All right. So these are the first 3. I just didn't put 500 on there. So this is our polar point. I'm going to really make it known in red. There it is, right there. Because remember, we can have the normal side and we can have the extended side. So at 320, 320 is the blue one. You see how that's in the negative x's? 320 is in the negative quadrant for x. So that's why this is going to be -3. Because it's in the negative x quadrant. Then 40, -40. So -40, that's in the positive x quadrants. But it's -40. -40 comes from here. Oh, my bad, wrong color. It's coming from this ray right here. So negative 40 is the same thing as 140 degrees. They're the same thing. They're coterminal angles. They share the same, like, opposite sides. Like when we did up here, when we did part C, negative pi over 4, no, my bad, part B. When we did part B, how 4 2 pi over 3 is the same thing as negative 4 2 pi over 3. So since it shares this same ray, this is actually going to be negative 3. Now, when you add 180 and subtract 180, those are opposite the radius. That's why we make them opposite. Another way to say that is that they share the same values to the top left and the right. It's so hard to talk about math when I'm not showing you. But if we want to break it down, it's the same reason as B. That 4 2 pi over 3 is the same thing as negative 4 2 pi over 3. So basically, if you get stuck on whether it should be negative or positive or whatever, so first of all, 360s, don't worry about them. Your 180s are the only ones that you have to be careful of. So graph them. Graph them and you'll be able to see, well, 320, that's negative x's. And then negative 40, since that's a negative angle, we have to actually find the positive angle that it exists on. It exists at 140. Negative 40 and 140, they're opposites of each other. So graph them, then you'll be able to determine whether it should be positive or negative for your r. 180s, they're usually opposite your radius. They're usually going to be negatives, usually. But always graph it. Graph it to just double check. So part A, we found polar coordinate points. Part B, we're going to find polar to rectangular. So we're given rectangular. We want to find the polar coordinate points of this, 2 of them. Alright, so let's really figure out what we have. Negative 1, 1, well, that's in Q2. That's in Q2. Or at least we know that. So we're going to find which trig function works in Q2 that equals negative 1 over 1 or 1 over negative 1. Because all of those equal negative 1. So going back to we'll go back to a unit circle in a second. So we're looking for a tangent theta that equals negative 1. So if we go back to our unit circle, in Q2, so looking over here, oh, that doesn't have radians. All right, looking in Q2, right here, so we need 2 of the same values that equal negative 1, and that's right here, 135. 135, it's the same thing over the same thing. So that's why we're going to use 135. So we know tangent 135 equals negative 1. We know that. All right, so we need to find our radius. Our radius, it's the formula x squared plus y squared. It's technically r squared equals x squared plus y squared, but we know we have to square root that at the end. So we have our r equals -1 squared plus 1 squared. I'm getting this from the rectangular point, -1, 1. We simplify. -1 times 1 is -1 times -1 is 1. 1 times 1 is 1. So we get square root of 2. Positive, negative, because we square rooted it. Square roots are always positive, negative. All right, so we have two of our values for radius. We have positive square root of 2 and negative square root of 2. So positive square root of 2, that's somewhere in this quadrant right here, quadrant 1. Somewhere there. Negative square root of 2 over 2, we say it's somewhere in the left. Because that's where my positive x's are, that's where my negative x's are. Don't overthink it though. This is actually really, really, really simple to not overthink. Your positive one goes with the exact value that you found. So the exact value we found for our -1 was 135. To find our second value, because we're talking about tangent and we need to, everything with tangent is by 180. Remember when you started to do your calculator stuff and you had to add 180 certain times to get to the quadrant you needed? So to get to our -1, 135 plus 180, and we get 315. So once you find your first one, it's exactly what it is. Your second one, add 180, and there you go. And that's how we have two other points for our rectangular point. We found our polar points. That's what we found. So, first things first, find what quadrant you're working in. Find the tangent function that works for the value you have. So -1, that's tangent 135, because it has to be the same over the same, but one of them has to be negative. And we're working in Q2 because that's where the point is. We find our radius by doing x squared plus y squared and the square root of that. So we get the square root of +1, or positive and -2. And then we get your first one exactly goes with your theta that you found of 135, and your second one, how we get that is you add 180 to your value. All right. Graphs of polar equations. An equation in which r and theta are the variables is a polar equation. Define the polar equation of the line ax plus by equals c as ax plus by equals c. A is r cosine theta, b r sine theta is c. You convert from rectangular to polar. So to convert rectangular to polar, x stands for r cosine theta. Y stands for r sine theta. We know that now. So to convert from rectangular to polar, these are the steps you take. You convert your rectangular to polar, you factor out the r, and then you simplify. Define the polar equation of x squared plus y squared equals a squared. So x squared plus y squared equals a squared, r squared equals a squared, and then r would be plus or minus a. We're going to use all of this. So find polar equations of lines and circles, and we're also going to graph it. So we have y equals x minus 3. So the first thing we need to do is get it in the form ax plus by equals c. So we need to move it over. That means we have negative x plus y equals negative 3. Now that we know that, we need to switch them out. X stands for r cosine theta, y stands for r sine theta. So x stands for r cosine theta, y stands for r sine theta, and it equals 3. Now we factor out the r. So we'll have r cosine theta plus sine theta equals 3. And then solve for r. So to solve for r, we're going to divide by cosine theta plus sine theta. So we get r equals 3 cosine theta plus sine theta minus, why did I put a, it's plus, it's plus, it's plus. Ignore me. So on the bottom, we have negative cosine plus sine theta. That should look horrible to us. We should not like the way that looks. So what we're going to do is just switch the signs. You're allowed to just switch the signs. It means the same thing. So we'll have cosine theta minus sine theta. That means the same thing. We just switch the signs. So our rectangular is what was given. It's y equals x minus 3. Our polar is actually what we just found. It's r equals 3 over cosine theta minus sine theta. Alright, now we're going to graph it. You do not graph polar, you graph the rectangular, because we're given the rectangular, that means you graph the rectangular. So our rectangular is y equals x minus 3. That means our y-intercept is 0, 3, and our slope is 1. Oh my gosh, how long has it been since we talked about lines? So it's a little harder to use slope, so what we do is actually use x and y-intercept. Usually we go off of slope, but our x-intercept, you know how to find x-intercepts. You should know that. You make y equals 0. Our x-intercept is 3, 0. So we're actually going to plot this by using intercepts. So we have our values of 1, 2, 3, 4. There's 4 rings. So 0, 3. Negative 3, sorry. 0, negative 3 is right here. 3, 0 is right here. And then you just connect your dots. So that's actually how we graph a rectangular equation, meaning x and y, on a polar equation. You use your intercepts, and it's the same rules as you, like however many rings you need to go. So you go 0 rings left and right, and it's just negative 3, so you go down 3 rings. And then for your x, it's 3, 0, so you go 3 rings to the right, nothing up and down. So we have x squared plus y squared equals 4. I know that's a circle. How do I know it's a circle? It's positive x squared, positive y squared. No other exponents. So that's how I know that this is a circle. So this is a circle graph with the center at 0, 0. If you need a refresher on circles, go to my 1105 videos. It's chapter 2.4. Go to my YouTube and there's a refresher on circles. So this graph is a circle with the center at 0, 0. So what we're given is x squared plus y squared equals 4. X squared and y squared X squared and y squared just equals a squared. A squared just equals r squared. So technically, we have r squared equals 4. The reason why we can do that because x squared plus y squared equals a squared, and then a squared equals r squared. So that's why we're allowed to switch that to r squared. We simplify, we get the radius is 2. Remember, it's always positive for our radius of 2. So the rectangular is x squared plus y squared equals 4. Our polar is just 2. So how do we graph this equation? Well, you graph the circle. Also, if you wanted to graph the polar, I can tell you how. So our polar is 2. So that means it's 2 all the way around. So 2, 2, 2, 2. And then you connect the dots. That's how we would actually graph the circle as well. Your origin is at 0. You go up 2, put a dot, right 2, put a dot, left 2, put a dot, down 2, put a dot. Alright, I have some terminology and stuff just to show you. Stuff that we really don't, I'm not gonna test you on, but it's stuff that I need to teach you. So, cardioid. So is this a type of graph? So r equals 1 plus cosine theta. So this is just cosine theta, but this is what you do when you plus 1 to it. So this is the actual boxes we're going to be looking at. This one right here. Because it uses transformations, which I don't like to use. So this is if you did everything on the unit circles, 30, 45, 60, 90, 120, 135, 150, 180, 270, 315, 330. We don't go to 360 because 360 is just 0. So if you wanted to do 1 plus cosine theta, it equals 2. 1.9, 1.7, 1.5, 1 for 90, 0.5 for 120, and so on. So you connect the points, all of them, and this is the graph you get. This is what you would get. If you were to graph 1 plus cosine theta, this is what it looks like. Alright, so this is what a rose would look like. R equals 3 cosine 2 theta. So this would be the final answer. If you plugged in 0, 15, 30, 45, 60, 75, 90, this would be your actual R values. So you plot the points, and when you connect it, so plot the points from the table in order to give the graph of a 4-leafed rose. Note how the graph is developed with a continuous curve, starting with the upper half of the right horizontal left and ending with the lower half of that leaf. So if you connected the dots, this is what it would all look like. And it's a rose. So see how you could do an art project with this? I could tell you create polar equations to create an image. Graphing r squared equals cosine 2 theta. That's this right here. So with your calculator, it's r equals. So that's why you have to take the square root to just get r by itself. So this is actually what it would look like. You would have to have one positive square root and one negative square root. And that's how you get your... It's called a lemniscate. That's really hard for me to say, but it's a lemniscate. And it's an infinity symbol, right? Cool, huh? Alright, I'm going to show graphing some of these in class, so because that calculator works. If not, I can always bring my calculator, and you can see it on the video projector. Alright, converting a... You're not going to have to graph these for the test, by the way. Not on the final. You do not graph stuff like this. Converting a polar equation to a rectangular equation. So we're given a polar equation, r equals 4 over 1 plus sine theta, and we need to convert it to x and y's. I'm just going to rewrite it to work with it. Alright, so the first thing we do is we need to get rid of the fraction. We need to work backwards. So we're going to work backwards from what we did here. We're literally just going to be doing the opposite. So the last thing we did was divide. So that means the first thing we do is multiply, because it's the opposite. So we're going to multiply by our denominator. And when we do, we get r times 1 plus sine theta equals 4. We distribute the r, we get r plus r sine theta equals 4. We know r stands for x squared plus y squared. That's just r squared. But we don't have r squared, we just have r. So r is the square root of x squared plus y squared. So let's switch that out, because we need x's and y's. That's our goal, is to get a rectangular coordinate, which is x's and y's. So we simplify this down to x squared plus y squared. R sine theta, we go back up. R sine theta just stands for y. So we're going to switch that to y. And that equals 4. We need to get rid of these square roots. We're not allowed to have them. So in order to get rid of it, we need to isolate the square root. In order to isolate the square root, we need to subtract y. So we have the square root of x squared plus y squared equals 4 minus y. And to get rid of the square root, we're going to square both sides. So when we square both sides, I'm going to bring it over here. The square root goes away. We're left with x squared plus y squared equals, when we square 4 minus y, we get 16 minus 8y plus y squared. Let's start combining like terms, moving stuff over, do what we can. So we have opposite sides with y squared. They cancel each other out. Also, if you subtracted it, they just cancel each other out. So we're left with x squared equals 16 minus 8y. Alright, we keep simplifying. We can keep simplifying because we can factor out the right side. We can factor it by taking 8 out. I'm going to take negative 8 out, and you'll see why in a second. Because technically this is negative 8y plus 16. That's how we're used to seeing it. And that's why we take negative 8 out, because it makes the first term positive. So we're left with y minus 2. And that's it. We don't square root anything. We leave it as is. We do have to factor it completely, but once you have x squared or y squared equals this, you're done. That's our rectangular point, or our rectangular equation. So x squared equals negative 8 times y minus 2. That's the rectangular. That's the same thing as polar y equals 4 over 1 plus sine theta. So rectangular is x and y. Polar is sine cosine. Now to graph this, because we are going to graph it, we don't know how to graph stuff like this. That's okay, because you're not supposed to know. You just pick out a t-chart. We do a t-chart. Now our goal is to get something that's going to be square rooted at the end, because we know it's x squared equals this number. So we want to make sure when we plug in values that we plug in values that work with square roots. And you notice it's x squared equals y. There's a bunch of stuff with y and barely anything with x squared. So we're actually going to pick numbers for y instead of x this time. It does not matter how you do it, but trust me, that is much easier. I'm going to write all that down. So we're going to pick y values that work with square roots. So meaning, because we're going to have x squared equals negative 8 times y minus 2. So we want to pick a y that when we simplify this works out to being a perfect square. So the first number I would pick is 2. Now why 2? Because 2 minus 2 is 0. So we have x squared equals negative 8 times 0. So x squared equals 0. That means x is 0. So we have 0, 2. That's why I picked 2, because it canceled out to 0 at the end. So you want to think a little bit of ahead. Now we need a few more points. Whenever you graph something, you need at least 2 points. So we have x squared equals negative 8 times blank minus 2. Now I want to think of another number that when I plug in can be simplified. So if I think of the number 0, we're left with x squared equals negative 8 times negative 2. Negative 8 times negative 2 is positive 16. And the square root of 16 is positive negative 4. So you want to plug in a number that can be simplified to then be square rooted. So the two x's we have are negative 4 and positive 4, and the y that we plugged in was 0. And I do have that graph already graphed for us. This would be by hand, the right would be calculator. So the right is your polar, the left is your rectangular. I do not have you graph explicitly like we did in example 7. You're just going to be finding the rectangular point. What you'll be graphing is like example 1. Alright, some terminology stuff. So classifying polar equations, you have circles and lemniscates. So circles are r equals a cosine theta, r equals a sine theta. This is what they would look like. If it were negative, it would just be to the left. If it was negative, it would just be on the bottom. R squared equals a squared sine 2 theta. R squared equals a squared cosine 2 theta. So if it's sine theta, because sine is the y, that's why it branches off the y-axis. Cosine is x, that's why it branches off the x-axis. A lemon scones. It's a fancy C. It's a lemon scones. I have to say it fancy because it's a fancy C. So r equals a plus or minus b sine theta, or r equals a plus or minus b cosine theta. So this is what they would look like. If a over b is less than 1, it's going to look like the left one. If a over b equals 1, it's the middle left one. If your a and b is between 1 and 2, it'll be a smaller one to the right. And then if your a and b is greater than 2, it's going to be a big one that opens up to the top. Again, this is all terminology just for you to keep in your notes for when you go to pre-calc, you can bust this out again. Rose curves. If you have 2n leaves and n is even, so if your n is greater than 2 and even, so 2, 4, 6, 8, 10, 12, this is what they would look like. Sine theta, cosine theta, if n is 2 and n is 4. So if n is 2, you have 4 leaves. If n is 4, you have 8 leaves, as it's 2n. If they're odd, you have an odd number of leaves. So if you have 3, 5, 7, 9, and so on, you would have 3 leaves, 5 leaves, and this is what they would look like.